Hello everyone. Today we're going to talk a little bit about a very important portion of machine learning, and that is sort of some of the semantics around the different things that you'll read in some of the academic literature or some of the commercial literature. I also want to talk a little bit about two very important topics that are very specific to the R statistical programming language, and those are the topics of data types and the topic of objects. But I want to start out with the IRIS dataset that we've been using and just go over a few things with you, because one of the more confusing areas for beginners in learning machine learning and predictive analytics is really centered around the semantics of what things are called. Sometimes you'll read that a data frame might be called something in one piece of literature, and it might be called something in another piece of literature that uses a different tool other than R. And some people refer to independent and dependent variables as different things. Some people refer to features and attributes as different things. So let me take a few minutes to just sort of clarify some of these things. So you can see I've got the IRIS data set here in Excel, and it's split up into really these two separate portions. So this particular last column I'm going to refer to as sort of the predictor. This is what we're trying to actually train a machine learning algorithm to make predictions on. So this particular side is a set of features that we're going to be working with. So these are the ones that are very important to the algorithm itself, and this is what the algorithm is trying to figure out, the relationship, or the function, if you will, between this side and the actual predictor. So what are some of these things called? So in the statistics world, this is often called the Y variable. It can also be called the dependent variable. Let me move over to this side. This feature set, you'll often hear me in all of my videos refer to anything on this side of the data set per se as features, because we have this concept of feature engineering that we're going to be covering down the road, and these are very important to machine learning algorithms. This is where most of your pre-processing is actually going to happen. You'll be doing a lot of creative engineering when it comes to quote-unquote massaging some of this data to get it in the right form. You're not modifying per se the actual outcome of the data, but you are changing it in many ways to make it very, very useful for different types of machine learning algorithms. So getting back to my point, so this side of the data set can often be called features. It can also be called X values. You'll see this a lot, and this is sort of goes to this whole concept of a Y value over here. So let me take it out of this. All of this can be referred to as, all of these can be referred to as features or variables, every single one of them. They can also be referred to as attributes. So you can see it can be very easy to misunderstand in this particular instance. So since this is the dependent variable, it must depend on all of these. So that's the relationship between those. You've got independent variables on the left side, and you've got one variable that you're trying to make a prediction on that's called the dependent variable. This is also often called the predictor. Actually, you know what? Let's do this. We'll just leave it as Y for now, because that fits well. So once again, just a quick review. You've got independent variables on the left. You've got dependent variables, usually one on the right. These are often on the left referred to as X values. These are often referred to as a Y value. These are often referred to as features, but all of these could be also called attributes. They also can all be called variables. So it really just depends on the tool that you're using to do all of this. and the process that you're following. So that's a little bit about just a sort of a brief coverage of what we're going to be covering a lot of and talking a lot of in this video series, a lot about. So let's jump into a quicker and a little bit of a deeper topic, and let's talk about data types inside of R, and let's talk about objects inside of R. So, and I'll use this same data set to do this. So I'm going to only talk about really the most important ones that are specific to machine learning. Remember, RStudio and R are very specific to statistics. So a lot of this stuff you may never use if you're talking about it with respect to machine learning or even predictive analytics. So I'm only going to cover a few of these. So the first data type that we need to talk about is numeric. These are really good examples of numeric data types. Anything with a number there. And numeric data types also come in the form of integers. You remember that just from your algebra days. You can have complex numbers that are data types as well, which is anything basically with an imaginary or an I type prefix. And you can have others as well, but those are sort of your three main areas. Numeric and integer are going to be the ones we're going to be focusing on mostly in this particular series. But there's one more that you'll often see, especially when you're importing data in older versions of RStudio. If you have any type of data that's a character or a string, if you will, these would be called characters because obviously they don't contain any numbers. In older versions of RStudio, you can actually bring in strings directly as characters, or you could also bring them in as an object type called a factor, which we'll get into in just a minute. So these are really like three of the four main ones that we'll be talking a lot about in machine learning. There are a handful of others that you're going to see a lot of if you're doing other mathematical work in RStudio, but since this particular video series covers machine learning and predictive analytics, we're really going to be talking about these three: numbers, integers, and characters. So that kind of does it for data types. Let me label this so you'll know what I'm talking about. So there are data types. So let's keep moving on, and let's talk a little bit about some of the objects that are inside of RStudio. And this is very important because these are sort of the mainstays of RStudio. These are things that you're going to be working with more than anything. Some of them are containers. Some of them are based off of semantics that come from math. So let's take a look at them. So the first thing that you're going to be working with more than anything is something called a data frame. If I just took this and imported this into RStudio, just like this, you would see it's an actual data frame itself. As a matter of fact, I think I have RStudio. I have it open. This is an example of a data frame from a previous video, from a video working on the iris data set. When I brought this in, it comes in as a data frame. Anytime you're using the import data set, it's going to come in as a data frame. And you can use various other instances and functions inside of R to determine what type of data types that you have now, and I've covered some of that in another video. So that's what a data frame actually looks like. That's the main container that you're going to be working with inside of R. So that's the first thing, and it's separated in rows and columns just like this CSV file is. So the next really main thing that you'll be working with is something called a vector. Of an object type inside of RStudio. And a vector is really one of the most basic data types or objects inside of R. And you can think of a vector as a single column of numbers, if you will. And it's not like a data frame where it's a matrix list or a matrix grid of different numbers. It's just a single column vector, and it can contain numbers, or it can even contain characters, which is really cool. So the next one that we might be dealing with a little bit are lists. Lists are very similar to vectors. You can include a lot of different things inside of lists, just like you can vectors. You can even include lists inside of lists, which is kind of cool. You can even include functions inside of lists. So really anything you want to keep track of that you don't need to do a whole lot of analysis on, that can be considered a list. Now, there's one that's really, really important. Actually, there's two that's really important that I want us to focus a lot on. This next one is important to the iris data set, and it's a factor. So in the importing data into our video, I actually converted a character to a factor, went from a data type to an object. This is very important because if you're going to be doing any type of classification in machine learning, classification works off of or works on nominal data types. And a factor is a nominal object. So when you convert something from a character over to a factor, or from a number or an integer over to a factor, you are essentially converting it from a number to a category. And that you have to have that for a classification algorithm in machine learning. So a factor is super important, and it's interesting to note as well that factors have different levels. So for instance, we might have a factor called shirts, which is that's not it, which is really important. So we've got shirts. We might have small, we might have medium, and we might have large. Those are different levels inside of a factor. So you can see that shirts may very well be the top level, the name of the column itself. That factor would have 3 different levels of nominal data, and that's really important because if in this particular problem you can see the species of iris flowers actually has 3 different levels of factors. It has setosa, I'll scroll down, it has versicolor, and at the very bottom it has virginica. So that's an example of the 3 different levels of factors. And the last one that I really think we should cover before we get to the end of the video here is this concept of a matrix. And a matrix looks very similar to a data frame. But the big difference is a matrix will allow you to do mathematical calculations on every single grid point inside of the matrix. So even if I were going to take a look at this, if I were going to do maybe some type of mathematical calculation on this particular iris matrix, if it were a matrix, I could multiply any piece or portion of this particular matrix by another matrix, which is really cool. There's an entire subject out there called matrix type math, which is in linear algebra, that you can really make a deep dive into. But anyway, those are sort of a high level introduction to data types, objects, and some of the semantics that you'll read about in many of the academic papers that are out there, and many of the tutorials that are out there. I think it's very important for you to understand that a lot of these things are called the exact same thing, especially when it comes to the difference in here. When you've got independent variables, many people will refer to those as features. Some people even refer to all of these as features, and again, they are all attributes. Some people refer to these as just this side as attributes. So it's very important for you to understand what you're reading before you get too deep into it. Very, very much take the time to clear that kind of stuff up and make sure there's no confusion before you get too deep into a paper or to a tutorial and you realize that what they are calling an X value, you are not calling an X value, or vice versa. So hopefully this helps out a little bit. The next video that I have coming up will definitely be sort of digging into pre-processing and moving things around and doing some pretty complicated stuff with some new packages, not new packages, but new packages to you in RStudio. And so we'll be doing some data wrangling and data munging here very soon. So hope you like this video. If you do, please like it on YouTube, and feel free to subscribe to my channel. I'd love to hear from you. Talk to you later.